4, not there yet. Oh, there we are, 22 and 38. So it's 2 standard deviations. So what percent would we found between 22, 95? Good. Now the next one tells us the number of data points that we're observing. So that's kind of new. So it says there are 40, so like 40 little balls drop down into the Plinko. And then it's asking us how many of those lie within 2 standard deviations of the mean. Okay, well what percentage lie within 2 standard deviations? 95%. So we just have to take 95% of 40. 90.95 times 40. So when you multiply 0.95 times 40, what do you get? Is it? 38? Thanks. .95 times 40, we got 38. Thanks. Next, data size is 80. It's asking within 2 standard deviations. Again, 0.95 times 80 is what? 76. Data set has size 60. How many observations lie within 3 standard deviations of the mean? So 99.7%. To write that as a decimal, remember we move it 2 decimals to the left, so it's 0.997 times 60. How many what do you get there? Round to the nearest whole number. 60. 59.89 or something. So if we round to the nearest whole number, then it would be 60. Because when we're talking about like how many data points, there's only a whole number of data points. I put approximately because, yes, it's about 60. Data set has size 50. How many observations lie within 1 standard deviation? So 0.68 times 50, and you got what? 34? Nine through 12 just makes you do one more step. Okay, so it says 80 observations, okay, and the mean is 30, standard deviation is 5. It kind of combines the 2 concepts previous. So how many observations lie between 20 and 40? What? So is it 2 standard deviations away? Yeah. 30 plus 2 times 5 is 40, and 30 minus 2 times 5 would be 20. So yeah, so that would be 95%, or 0.95 times 80.
Oh, okay, so if it has like data set, I mean like the observation.
Uh-huh. So basically, how many Plinko's chips will be within this range? 0.95 times 80, which we just did in the number 6. We did that calculation. So I'll do one more with you and then have you do the last 2 on your own. It says the data set has 250 observations. The mean is 100. Standard deviation is 16. So how many 16s are there to get to 148?
3.
So 3 times 16 is 48? Good. You're right. If I wanted to, if this was like confusing me, I could just draw it out. Okay, 100, 116, 132, oh, 148. That's 3 standard deviations above, and do the same thing on the bottom end. And then I can realize Oh, that's 99.7% or 0.997 times 250. 249? So in that case, you'd have that one Plinko ball out on the very end falling outside of the 3 standard deviations. Remember, we say approximately 99.7. There's still that 0.3% that's has the potential to lie outside of the 3 standard deviations. Go ahead and finish 11 and 12.